Hello and welcome. I'm Chaco Daniel, Program Manager with the Hyperscale Compute team. I'm here today to talk to you about managing secure, scalable Azure Service Fabric clusters and applications. So today, let's just go over the agenda at this point. So today we'll talk about a new module which we have released. This is the Azure Service Fabric PowerShell module. We'll talk about the best practices of planning your cluster, securing your cluster. How do you write down your best business continuity plan? And how do you think about monitoring and diagnostics? And then towards the end, I'll cover as to what other exciting features we are building in Service Fabric. So let's just start by looking at what this platform, the Azure Service Fabric itself is. A lot of you guys may already know about it, but I just wanted to just give you a high-level take on this one. So this is the ingredient, one of the key ingredients which our tier 1 products like SQL, Link, and other box products use to transform themselves into running as cloud-native applications. So let me also talk to you about the roadmap of the new capabilities which we'll be releasing this year. Some of it we already have released. For example, the Service Fabric Windows SDK, the Service Fabric Windows on Azure, the Service Fabric for Windows Server on-prem. And then in preview, there are two things which we have. One is the Service Fabric Linux in Azure, and then we're pretty soon we'll release the standalone version of the Service Fabric on Linux. And we're also a part of a core Service Fabric Azure stack as well. So we'll be a part of the core ring itself. So that's coming. So let me just go on to the real meat of our talk today. So I'm happy to announce a brand new Service Fabric RM PowerShell module that ships as a part of the Azure PowerShell. So till today, we actually are not a part of the Azure PowerShell. So this is something which is going to be brand new. And this is the main motivation for building this module was to address the customer pain points. Like for example, when you're creating a cluster, a secure cluster, it used to be a little painful in uploading your certificates to the Key Vault and then getting the URLs from it and then giving it here and so forth. So this particular PowerShell, basically, I'll just show you one in action where it's just one command and then it does it for you. The other ones, like for example, adding and removing nodes from a cluster, scaling in, scaling out, scaling up and down, or adding new node types to a cluster, all these used to be a pain point for our customers. So this is something which we provide multiple PowerShells for at this point in this module, which will make it very easy. The other one is rolling over certs, where a primary cert is expiring and you need to add another secondary cert. That's something which you can do with this PowerShell very easily. So let me just show you one in action. So let's just take this particular PowerShell. This actually is the new Azure RM Service Fabric cluster. That is the PowerShell command. This actually has 4 parameter sets. This is mainly to support the majority of create new Service Fabric cluster scenarios. For example, the one which I have on the slide at this point, this actually takes the minimum number of parameters. It creates a secure cluster and also assigns it a self-signed cert, which then you can optionally download it, or actually it will give you as an output as to where you can get it from the keyboard. So let me just give you a demo. All right, so let me start a demo. Give me a second. So the very first thing is let me import my modules at this point. And then here is, let me just give you a little, let me move this a little bit here so you would see it. So Control plus. So this is the list of all the PowerShells which you have in the Service Fabric RM module. So there are a set of adds for adding application certificates, client certificates, cluster certificates, adding nodes to existing node type, or adding a brand new node type, getting the Service Fabric details of the resource itself, and so forth. So I'll let you guys look at it at leisure later. So let me first log into Azure, and then so that I can start deployment. So it's going to ask me for my credentials. So it's going to take some time. It most likely will be asking me a 2FA. Let me bring the authenticator up. So there you go. So looks like it's logging me into one of my subscriptions. So now let's look at all the overload, the 4 overloads which I just talked about. So you would see there are 4 of them here. I will not go through each of them because it's too dense to talk about. So there are 4 of them. 1, 2, 3, 4. There are 4 of them here. And then each of them has slight different variations. One of them, for example, takes in a certificate which you give. And then if you have a key vault it needs to be uploaded to, it actually can do that too. I would think that actually is your production scenario. So for the sake of our demo, it's basically what I have done here is, as a part of parameters, let me just show you what I have done here. So here it is. So basically I have just selected the number of nodes to be 1, so that you can actually change it to any number from 1 all the way up to 99. So actually I can think 2, and then I'm basically running it. So that's all this is doing. Okay. So while it'll take maybe around half an hour. So we'll not wait for it at this point. So I'll just continue with my deck, and then we can come back to this later and see as to it getting deployed. Okay. So that was I think, oh, good. So I have a slide which says it's a demo, so that I've just finished the demo. So we can go on to the other topics which we had to talk about. So let's go to the next one. So a couple of things which I want to switch our focus to, talking about the best practices for cluster security on a standalone cluster, and then we just go on to the Azure as well. So the reason why I thought this was actually a good topic to cover is because most of the customers seem to get it wrong. So wanted to make sure that here is a authoritative guidance from our team as to how you would want to set up your cluster security in the Windows Server standalone. So one, although we do support certificate security, it is strongly recommended that on-prem, when you set up your cluster, use ADs. So for cluster security, that is actually the node-to-node security, use GMSAs. And for client access, whether it is admin or read-only, use AD. So in that way, a lot of the certificate rollovers and other issues and sharing of certificates, all these potential loopholes for security are all gone. So basically, absolutely use AD for the purpose whenever it's possible. The second thing is, for any production deployment, always use an automated deployment. Yes, I don't have a recommendation for the tools you want to use, but if there are no tools at your disposal, absolutely take the PowerShell which we just announced today, and use them to script your deployment. The script should also include any secret generation which you may be using in your production applications. So I'm focusing on the production ones only because a lot of times in the test things, I can understand that customers might take a shortcut, but in production, absolutely follow these best practices. The other thing is, which I also strongly recommend, is create DMZs using network security groups. So this one actually allows you to absolutely make sure that there's only a certain traffic which you allow goes out or in from the cluster. The second thing which I've seen some of the tier 1 customers do today is to use GEMP servers to RDP into the cluster VMs. So let's just go on to the cluster security in Azure. In Azure, similar things. The only difference here is basically the cluster node-to-node security. You still have to use certificates. So the strong guidance which I have is, make sure that you use certificate security only for cluster node-to-node security. And for client accesses, whether it is for admin purposes or read-only management operations, absolutely use AAD. So that is the right thing to do, and that also gives you audit trail, and also less nightmares in terms of certificates being lost or certificates being compromised and so forth. Yes, you can still use certificates, but I would just say certificates should be used only as a break glass scenario. That means if AAD is down for some reason and you have a specific need to go do some management operations against the cluster, then that certificates can be used at that point. So as I talked about earlier, yes, use automated deployments whenever possible, including generation of the secrets and so forth. So that is actually a very best practice. In fact, SFRP application itself, which is the one which enables you to create clusters in Azure, does all these as best practices. So I'm just telling you the best practices which we use internally. So the other thing is absolutely use NSGs. So that you can truly control the ports which are getting opened for incoming and outgoing traffic, and certainly the same thing like I talked about earlier. Use jump servers for RDPing into the VMs or to manage your cluster. So now that I have talked about NSGs, I thought let's just go and clearly explain as to what it means and what do I really mean by that. So here is a small schematic about creating the clusters in Azure. So if it's an unsecure cluster, these are the resources you will find. One is the Service Fabric cluster is a resource. You have a VNet as a resource. There are VMSS 1, 2, and 3, and then there are load balancers. Once you create a secure cluster, of course you get security on as well as resources. So there you have Key Vault and AAD as resources, and then once you put NSGs, basically what happens? Those are the three other resources which get added to your resource group. Each of them actually map back to rules in your load balancer. So I'll show you in a bit. And then I talked about the jump server. The way you would set up jump servers in Azure would be basically the jump server IP address is a part of your VNet, and that's the only way. So now quickly, let me just show you a demo of a NSG-enabled cluster on the portal. All right, so, and then here are the NSGs, subnet 0, 1, and 2. So let's just look at one of them, and then, so let's just look at it. So this one, I specifically wanted to show you this because I wanted to talk about the rules which you have here. So if you look at the rules here, so in this particular cluster, I have opened port 80, 8081. These are actually for my applications itself. So I allow that incoming inbound security rules for those. And these two, 19,080 and 19,000, these actually are for management operations. If you do not plan to use any TCP connection itself, so you can disallow this 19,000 and you can just keep 1919 because that is the HTTP gateway. And then there are a few ports. There are 3 ports which the Service Fabric itself uses for internode communication and least leg traffic and so forth. So this is something which you should allow as inbound. Then the next 2 things, basically depending on whether you are using an ephemeral port, so you actually have to open some of them. The minimum which you will need is 256 of them. And then application, in this case, I've just opened up 10,000. You don't really need to do that if your application is using static ports. 445 is used basically for the image store, its application itself. So that's 445. It uses SMB, and that's why the SMB port is open. And then these ports from 3389 on actually is for RDP. So if you have enabled this jump server, then you'll actually turn this one off from an inbound, and then you can have the connections coming from a specific IP address, which actually happens to be your jump server in, and then you can do the RDP from there. And then the rest of it is all blocked. And then and in this particular scenario, I don't have any outbound security rules. So basically all the traffic from within the cluster is allowed out. So this is the NSG which I was talking about. Hopefully it illustrates as to what I truly mean that it's a best practice. In terms of, let's switch focus at this point and then now switch from cluster security to, let's talk about the cluster planning itself. So cluster planning, this is something which I've seen a lot of customers have problems with because they're not thinking about it in the same way which I have. So there are 4 facts. 1, Cluster planning is not an easy exercise. This is not something which you can get done overnight. It's something which you have to be very methodical about, and also periodically revisit. That's something which is very important that you do. So because the initial assumptions typically are not right by the time you get into production, and then you've been there for 3-4 months. So a number of applications increase, the number of density increases, your scale goes out, and so forth. A lot of other things. So absolutely revisit your cluster capacity periodically. Maybe as a best practice, you should revisit it every 6 months. That's something which you can say that is on the schedule. Take a look at it, how you're doing in terms of COGS, in terms of utilization factors. Absolutely, you should do that. Second is, adding capacity on demand is not instantaneous in Azure. In fact, in any cloud environment, what's going to happen is it takes time to deploy a new VM and the VM to go join the cluster. So if you are waiting till the very end, when there is a load spike to add a VM, that's just not going to happen pretty quickly at that point. So make sure that that is not how you plan. So assume that it will take at least 30 minutes before that particular resource joins the cluster and it becomes useful. Then the last one, what are the things I suggest you do as best practice? One, define what the cluster is used for. Is it used for test? Is it used as a CI/CD pipeline? Or is it for production use? And depending on each of these, your level of effort is slightly different. And also, you can choose to say that, for example, in test, you're not running them as a scale minimized. It's not running its full scale. Versus if it's a CI/CD pipeline and it is going to be a pre-production environment, then you want to treat that as production, and it has to be at least very close to what a production cluster will look like. So that's one of the reasons why it has to be very clear what this cluster is used for. And also the access to these clusters are different when it comes down to test, a pre-production or a production cluster. So the second thing which you have to do is determine the node types and the sizes. This is very simple. So at the bare minimum, you will need one node type. That is the primary node type. So now the only question you're trying to figure out is, do I need other node types? Or can I just put everything in there? So that's something which you can do basically by looking at all the applications you plan to deploy into this cluster. You or your teammates are planning to deploy into this cluster. Do a sizing exercise for each of them. Map out as to what kind of memory requirements are there, what kind of storage requirements does each of these applications have, what kind of ports needs to be open, are there any port conflicts between the two applications, and so forth. So these are things which you absolutely have to be aware of when it comes down to determining the number of node types and the sizes for each of these. Azure offers you a plethora of sizes. We recommend that you always try to use the VMs, which are the D-series VMs, which have SSDs, local SSDs in them. So that's something which we strongly recommend. And then lastly, if there are any unique compliance and security requirements, then those go into cluster planning as well, so that you can determine as to, okay, for example, if there is something very strict about your compliance requirement for your cluster, maybe Azure is not the right option. Maybe you wanted to deploy it on your own on-premise at this point before the compliance can be met. So those are things which go into your cluster planning. Yeah, so this is something which I just talked about. So where do you want this cluster hosted? The previous requirements will drive this particular requirement. So now I will switch focus again a little bit and address two terms. One basically is, what is a fault domain and what is an upgrade domain? So these are things which I've seen on-prem clusters, on-prem customers have problems with. So I just wanted to take this opportunity to just specifically call out as to what these truly mean. So fault domain basically means that this is the headroom or the extra capacity you will have to plan for in case of unplanned failures. Unplanned failures could be like, for example, the top of the rack crashes, or maybe the PDU burns out, and so forth. And upgrade domains basically means that how many of your VMs are you willing to bring down at a time for doing some upgrades, whether it's OS upgrades, whether it's Service Fabric upgrades, application upgrades, and so forth. So let me use some schematic to illustrate this at this point. So before I get into this, so if you're in Azure, you actually do not get a choice of the number of FDs and UDs. They actually are 5 and 5, and that's something which Service Fabric allocates upfront, and there is not much you can do there. So and 5 is a reasonable number at this point. And then if there is something which we can do about it, we'll certainly see if there are things we can do for larger clusters. But at this point, it's 5 and 5. So in this in this example, I have five fault domains. And the PD, for example, the FD5 PDU burns out. So basically, you need to have enough capacity so that you can have all of the replicas or instances moved into the other side. That is what the minimum requirement for a fault domain when you plan about it. When you plan about upgrade domains, similar things happen. In this scenario, of course, I'm thinking that I have 10 upgrade domains, and these 10 upgrade domains. In this upgrade domain, say for example, I'm just going to take down UD9 for a Service Fabric upgrade. So the minimum requirement would be that I should be able to place the replicas which are in there into somewhere else. So this actually is not a true representation of Service Fabric. For example, if you're running with multiple replicas, basically what that happens is the primary is just basically gets reelected somewhere else, and you don't really move the replicas at that point. So it's just basically a secondary, which is most caught up, gets reelected. But this is just for illustration purposes. That's what I'm trying to say, that you'll have to plan for it. Plan for that much of headroom. So what is my best practice? This is something which I strongly recommend. This is something which we do internally as well. So at the very minimum, the way you should plan your cluster is that you should be able to survive at least the loss of one fault domain, and then one UD being down for some reason. You don't know why it is. So, and then last, a random machine just going out. So this can be the act of physics, it can be the act of God, whatever those are. So as long as you plan for these, you actually are in a good place. And the probabilities of you losing your cluster are lower. So that's what I would think this is. So this is the best practice you should think about when you're setting it up in terms of capacity. So now let's switch to what are the best practices for cluster setup in Azure. So in Azure, basically, I strongly recommend that a production cluster and maybe the pre-production cluster is also use ARM deployments. So basically, download the template, tweak the template, customize the template, store it, and always use the ARM template to drive changes into your cluster or a resource group. The reason why I strongly recommend that this is something you should do is because if you don't do that, if there is a lifeside incident, you really do not know what configuration is running in production. So the first few minutes, maybe half an hour, you will spend trying to figure out what is running. So that actually is I call it the golden window, where you have the opportunity to bring your application or your service back up, and you're spending the time in trying to figure out what the configuration is. So in order to avoid that, treat your configuration as code. Use the same tools which you use for your source control for your cluster configuration. In that way, you're very clear that what's in production and what's in pre-production, what's in your test, and so forth. So that's something which I strongly recommend, and this is something which we follow internally as well. The other thing which we follow is, although it is easy to use implicit commands to tweak a resource, like for example, when you are in need of an additional VM, it's very easy to go send a command directly to CRP and add a machine into one of your VMSS. But think through the scenario where after four months you have an incident, and you now have to recreate this cluster elsewhere. You really do not have the configuration which you deployed. So that's one of the reasons why I always say that keep your cluster configuration and treat them as code, and then keep them in some source control of your liking. Be it GitHub, be it Source Depot, whatever else, that makes sense. Okay, so let me move on. Test clusters in Azure. So one of the biggest complaints which we have heard from our customers is that Service Fabric, when used for test, since we support only the 3-node cluster, is very, very expensive. So we have heard you, And at this point, we're going to announce that we're going to support a one node cluster in Azure. So there are some caveats. The caveats is this one node cluster can only be used for tests. And then also this one node cannot be grown to 2 nodes, 3 nodes, 4 nodes, and so forth. Basically, it's a one node, treat it like that. And then it will also have the same characteristics as your 5 node cluster. It will get upgraded, it will be managed by SFRP. So that is not an issue there. So let me just give you a demo. Or maybe just let me walk through the rest of the things I have on this slide. So the PowerShell command which we saw earlier, basically the only thing which changes there is the cluster size. You can just indicate the cluster size as 1, and then it will deploy your one node cluster. If you like a 3 node cluster, you just give a cluster size of 3. So basically that particular command, new Azure RM Service Fabric cluster, is something which you can use for your production clusters from 5 upward. It will deploy a one node type cluster, and depending on what size you request it, it'll make it for you. It does not support a 2 node cluster, so don't try it. It supports 1, 3, and all the way up to 99. So now let me show you something which we can do in the portal. Create. So in order to create a one node cluster, it's the same as you would do any other cluster in production or in on the portal. Sorry, Chaco. All right, I'm going to deploy it in East US. Let's just go to the next tab. This is the more interesting one, which I wanted to spend time on. It's a one node type, great. So, and then let's go here. So node NT1. So here is the thing. So let me just try to increase the font a little bit here. There you go. So here there is actually an option for a single node cluster. As soon as a single node cluster is clicked, it gives you a little warning saying this is used only for test scenarios, so should not be used for production clusters. And it is created on a single node and a single VM. So there is no concept of multiple node types having a single node. So that's not something which we support. And then as soon as you click that, you would see that this particular VM scale is also blocked. So other than that, there is nothing different. It basically, you do the same things like you would do before. You can choose your durability as well based on the VM size you choose. So I don't need to spend time on this one at this point. So I will leave this here because I think I have to come back to this on a different demo down my talk. So I showed you that. Let's just now address the other big ticket item. So one, of course, is you're adding a VM to a node type. You can also choose to scale out a cluster by adding a new node type. So this is the other set of PowerShells we support. One is for adding a new type is add Azure RM Service Fabric node type, and then specify the node type itself. Basically, you need to give it the SKUs, you need to give it the number of nodes needed, and so forth. And then there is also a parallel one, which is the remove Azure Service Fabric node type. So let me give you a demo. So I have an existing cluster. So let me show you an existing cluster here. Let me just go here for a moment. Let me go back to my desktop. Here this actually is the cluster I'm going to add some 2 nodes to into the NT. So that I have 2 node types, NT1 VM and then NT2 VM. So I'm going to add 2 nodes to this. So let me run this command. So while it runs, what you should see is, if I go back to the portal, let me get to the VMSs at this point. So basically what's happening is now a command has been sent to the VMSS resource to add 2 machines to that particular node type. So let me just go into this. This is the virtual machine scale set. So as you can see here, you can see that this is now auto scaling. Sorry, this is updating. So the status is updating. Here it is. And then the standard V2, the node instance count is moving from 5 to 7. So that's all it took. And then after this happens, basically just to talk about the end-to-end story, once the VM gets added, then the extension, our Service Fabric extension gets invoked, and then those two machines or those two VMs join the cluster, and then a cluster upgrade happens, and then the VMs are good to use. So if you go to the this particular cluster resource itself, you would not see anything different going on there until a little bit after. So it just still says ready, and I still have only 8. So the other 2 will join, and it will become 10. Hopefully by the time we are done with this talk. So that's all it took. It was just a simple command, and it's just going on. So it's going on still. So at this point, let's just switch our focus into another big topic. This actually is the business continuity planning. So one big thing which everyone forgets is that the disasters happen. This is a fact of life. However much you plan, disasters happen. So the best thing to do is write down and keep your business continuity plan updated. So write it down and then revisit this every year or year and a half to make sure that your business continuity plan makes sense. So then there are 2 words which are very vital. These are the 2 things which you absolutely have to define. One is the recovery point objective. So this basically means if you are running a stateful service, whether you're using our programming model or you are not, or you're keeping your state elsewhere, you absolutely have to know when a disaster strikes, how much of data can you lose? That actually is defined as RPO. Typically that is something that a lot of customers define it as 30 minutes, 5 minutes, 10 minutes, whatever else those are. So 30 minutes, 5 minutes, or 10 minutes, those are then determine the rate at which you take your backups. That is what it really means. So that then you can restore them to another cluster, to another environment in the case of a disaster. RTO. RTO is actually just means, as I've defined it here, is the maximum tolerable length of time that your service can be down after a disaster occurs. So from an operational perspective or a DevOps perspective, the way you should think about it is, what does it take for you to start in a new place and have your service up and running? If depending on your disaster, it can also include creating a new cluster elsewhere, in a different region or maybe in the same region. So that RTO needs to include that time. The last thing is, so backup of your application state actually is reflective of what your RPO time is. So these are the two big times which you absolutely have to sit down with all your stakeholders and define it. That's something which I would strongly recommend. If you don't have it today, do it now, or just do it as soon as possible. So here are the kinds of disasters which I've seen different. So to simplify it down, I just have divided this into 4 buckets. One, a data center outage. That is the biggest thing which can ever happen. So Azure data center going down is not a event which most of the customers plan for, but I'm not saying you shouldn't. It can happen. An earthquake can hit one of your data centers, then that can go out. So at that point, so that is one type of a disaster. And again, second thing is a cluster being down. The cluster can go down for various reasons. Maybe you have overloaded it so much that none of the system services are responding. That actually is a interesting behavior. Or maybe there was some blip and more than 50% of your seed nodes of your particular cluster was lost and the cluster came down. And then there could be machines going down, the fabric controller moving it out and in based on based on some upgrades going on. That actually is a normal course of event in Azure. So, but it is a part of it. It could be a disaster unless you plan for it. And then the last one is oops. So for example, fat fingering or setting up, or you had bad practices where you have deployed something into production you should not have, and so forth. So now let's go back. So I have some mitigations for you. So that is there are two more columns here. One is RPO and RTO of 0. So this just means that your application absolutely cannot have a downtime. So both your recovery point objective and the recovery time objective is 0. So if that were the case, you have to figure out whether you are write intensive or you are read intensive. Lot of mission critical applications we have seen so far are pretty read intensive, and they do writes. But if your writes can accept some amount of latency, then actually you can survive a data center outage, right? So by setting up a cross-regional service fabric cluster. So page up. So that is the mitigation which we propose. So the key there. So if you are interested in setting one such cluster and you wanted some guidance on it, certainly ask our help. We'll actually be very happy to sit you down, talk about how it's done, and so forth. So not many customers in Azure have done it at this point. So if you are one of those people who are interested in setting one up, get in touch with us. Cluster down. So if it is a cluster which is cross-regional, then the probabilities of this happening are very, 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 very low. So at this point, you don't really need to think about it too much. But if it ever happens that you still lose a cluster, then the only thing you can do is set up a cluster and restore it from the backup. Because backup is something which you absolutely have to take. So this just means that if you're a cross-regional cluster, the probabilities of you ever using your backup is very, very, very low. Then machine down, a machine and node down. So in Azure, you get 5 FDs and 5 UDs. And if you're a cross-regional cluster, then basically you are now looking at 15 UDs and 15 FDs. So the probabilities of you losing a quorum of those machines or replicas are low. But being a paranoid person, I would just say that yes, you still should design your application in such a way that you should expect a write quorum loss. So that's something which would be something you should plan for. The last one, yes, everyone commits mistakes. There could be some oops. None of the things from an infrastructure perspective can help you. So at that point, you're resorting back to the backups. When it comes down to backups, you also have to clearly understand whether you're doing an incremental backup or a full backup. So there are pros and cons of both. If it is, for example, if you do not take a full backup often enough, then when it comes to restoring, you just have to do one full backup and then a lot of incremental backups, restore all of these from the incremental backup. So it's a thing which you need to figure out based on what your RTO is. So now comes to the other area where RPO and RTO are actually non-zero. A lot of customers have an RPO of say 10 minutes, an RTO of 30 minutes. If that were the case, very simple. You don't need to do a cross-regional cluster. You can also absolutely stand up a new cluster somewhere else, restore your cluster configuration from your code. Remember from your source depot or your Git or wherever else your configuration was. Restore, create a new cluster, and then basically you're just creating your applications and then restoring the state from backup. That's it. Then you're all set to go. So that would determine that length of time it takes is what your RTO is. If the cluster goes down for some reason, same things happen. You basically stand up a new cluster, do something, and restore from backup. So the rest of the two things which I've already talked about. So hopefully that explains and gives you a framework as to how you would think in terms of your business continuity plan and how you plan for it. And then no plan is good unless you exercise it. So absolutely plan for exercising your business continuity plan every 6 months or a year, because people move, people forget, and the only way to stay focused and be ready for a disaster would be to try it out and train for it. think about monitoring not only your cluster or your application, but also think about how you use it for monitoring your resource usage, your application performance, your effectiveness of your application, and so forth. And then when it comes down to effectiveness of application, there's nothing in our system which will tell you if your application is really doing your business for which the application was stood up. All our system will tell you is, yes, your application is up. We really do not know whether it is doing the right things or not. For that reason, you absolutely have to add some custom metrics. Like for example, if your application is helping make sure there is another watchdog or any other thing which actually periodically tries to do the same thing, so that you find out about an issue before the customer finds out about that issue. So that's the way to think about it. And then all these metrics which you pump out absolutely can be sent to a warehouse, and then you can do business insights and do more improvements from that end. So what does Service Fabric provide you out of the box? Out of the box, it provides you the operational events. Operational events, we categorize operational events as high-level cluster and node events. That's what operational events mean in terms of our definition here. You might say that operational events should also include application events as well. So certainly your definitions don't matter much here, but from a Service Fabric perspective, out of the box, you get some operational events. These are the cluster operations and node events. Then the health reports and load balancing decisions made by the system. Health reports, basically there is a system service called failover manager and the cluster manager. These things report health of your application replicas or service replicas or application services, nodes, partitions. All these levels, we report health. So at the bare minimum, you would see that there's actually at least one health report, whether it is OK, error, or warning, on each of these entities. So you can, of course, augment that by creating much more richer ones by adding watchdogs or any other health reports from your application. Outside that, there are two other means of getting events as well. One, if you're using reliable collections or reliable services, that programming model, you get a lot of events from there. And then also reliable actors, you get events as well. So if you're using our programming models, you get a lot of these events from those programming models. And then it also there is system logs. System logs are basically the system level events which our support engineers used in case you call us for support. So it doesn't mean that it's actually all these system logs go into your Xstore. So best practices. Always enable diagnostics. That's something which you should not turn off. That's the only way for us to support you. Second, generate custom traces in your applications and services. Set up your monitoring and diagnostic alerts based on your metrics. And then, of course, try and create watchdog services for your applications to measure basically whether your application is performing to what you had set it up for. So let me give you a quick demo, and then we can close at that point. So out of the box, we actually now allow you to give a apps insight key when you come into the portal. Basically, you turn the diagnostics on, and then you just have an apps insight key here. You actually give it there. Once you give it, then it's very easy for you to get apps insights at this point. So let me just bring it up and then show you a quick one which is there. So I have already set up this cluster at this point, and as you can see that there are some events which have come here. Let's go into the metrics itself. And here I have some metrics. Let me just click on it so that actually now I can do some filtering on it. So if you see, there's lots of events which have happened. See, there's tons of other events which have happened. And you can see this is all listed out here. So in the filters, you can actually now go and when it comes up, so say, for example, go to the task name. Basically, where is it? There it is. And then once you open it out, you can see that now you actually can filter on things like, for example, are there any actor deactivations? Are there activations or deactivations? Like, for example, if you click that, and then basically you can see the trace out here, you will see it. So anyway, so you will see that coming up. So that's something which you should absolutely try out. Is out of the box. All these integrations are there with Apps Insight. So road ahead. Very excited to announce that we would actually also have the Azure CLI. This will have the same functionality as Azure PowerShell. That's something which which will be coming out pretty soon, maybe in the June timeframe. Application services as AM resource. This is something which all of our customers have asked multiple times. So this actually allows you to do some RBAC functionality and so forth, and then you can use application services as AM resources deployed using the PowerShell, using Portal as well. Patch orchestration service. This actually allows you to do OS patches. It's coming in the next 3 weeks or so. Then standalone offerings of Linux clusters. So now to recap. So in this particular module, we talked about the use of Azure PowerShell module. Absolutely go try it out. This is in preview, so we need your help to improve it. Best practices of your planning your cluster, securing your cluster, and also writing your business continuity plan. Absolutely go do that. And I also showed you a demo of Apps Insight for monitoring and diagnostics. And thank you for the time. I hope this was useful, and send us some feedback. Thank you.